Okay, so in this lesson we're going to look at how we factorize quadratic expressions. This will be helpful for when we look at quadratic equations, and it's one of our methods on how we solve quadratic equations. Essentially, factorizing is the reverse of what we learned previously when we were multiplying brackets out. When we are factorizing, we're putting brackets back into the expression. Okay, so what we have to do is we have to think in reverse. If I was to end up with this type of expression, x squared plus 5x plus 6, I have to think what that would have looked like when it was in two brackets, okay? So I have to get it back into this format. So this is the reverse of FOIL, first, outer, inner, last, and there's a couple of basic things that we can start off with. Well, the only way I could get an x squared is if the first term in each of these brackets was an x, so that's the first thing. Now, how we work out the numbers that go in the end here is we look at the middle term, the coefficient of x, and the number that's on its own here, okay? So when we're doing this, we have to think of 6 as what's known as the product. Product in maths means multiply, and the 5 as the sum. So what I mean by that there is we have to think of a pair of numbers that multiply together to give us 6, but add together to give us a sum of 5. So how we do that, I look at the pairs of numbers that multiply together to give me 6 and see if there's any of those pairs that will also give me a sum of 5. The handy thing with this first example is that everything in it is positive, so don't have to worry about positives and negatives and things of that nature just yet. So I'll work through my different pairs that give me a product of 6. So the first and most basic being 1 times 6, okay? But if I look at 1 times 6, I think, right, well, does 1 and 6 add to give me 5? They certainly don't. They would add to give me 7, so they're out. The next pair of numbers that multiply together to give me a product of 6 would be 2 times 3. So if we look at 2 times 3 and says, okay, well, 2 times 3 definitely multiplies together to give me 6. Would 2 and 3 add together to give me 5? Well, they do. So that is going to be the numbers that go into our bracket. So it'll be plus 2 and plus 3. And again, when everything's positive in the original expression like this, we don't have to worry about signs. We know it's a positive going into both brackets. And that's our answer as it is. Also, just to point out, it wouldn't matter if you'd written, in this case, x plus 3 and x plus 2 and got the brackets the other way about. This way, in this is probably the most simple example you'd be dealing with. So in our second example, a wee bit trickier in the sense that we have a plus x and a minus 20. So we're not dealing with everything being positive here. Start off looking at the equation the same way. So we're trying to revert it into two brackets again. And if we think of FOIL in reverse, the only way we could end up with an x squared as our first term is if both brackets had an x at the start of them, okay? We're still dealing with product and sum. So the term that's on its own here at the end, that's our product, and the coefficient of x is our sum. So that is a plus x. And we know from previous examples that plus x means plus 1x. There's an invisible 1 in that case. So the sum in this case is 1. So what we need is two numbers that multiply together to give us minus 20. But when we add them, give us a sum of 1. So this is the added step here. We have to consider how do we get minus 20 when we multiply two numbers. So we get a negative by multiplying a positive and a negative, or a negative times a positive. So if I work my way through the different possible products that give me minus 20, I could have, say, 1 times minus 20, so a positive and a negative, or I could have minus 1 times plus 20. But looking at those, and again, if I was to add them, so 1 plus minus 20 would give me minus 19, that's way off the mark. Minus 1 plus 20 will give me positive 19, so again, that's way off the mark of giving me a sum of 1. And again, it's a wee bit of a process of elimination here, a wee bit of trial and error, but the more practice you get with these type of equations, the quicker you'll be able to solve them, the quicker you'll be able to spot it. In fact, some of you may be already able to spot what the two numbers are going to be. But again, if it was just to work through all the possibilities, if I was to look at, say, let's 2 and minus 10, or minus 2 times positive 10. Yes, they both cases multiply together give me minus 20. However, if I was to add them, so 2 plus minus 10 gives me minus 8, and this would give me positive 8, so neither of those work either. The next pair of numbers that will multiply together to give me minus 20 will be some combination of plus and minus 4 or 5. So we could have 4 times minus 5, or we could have minus 4 times positive 5. Okay, so this is probably where our answer is going to lie. If I was to take the sum of the first two numbers, so if I have 4 plus minus 5, that gives me minus 1. However, I want a positive one, so it's going to be this one here. Minus 4 plus 5, think of your number line, minus 4 adding 5 would take me up to positive 1. So that gives me the numbers that go into each bracket. And again, I will point out, it wouldn't matter if I'd written x plus 5, x minus 4 this way around, as long as the 4 is the negative and the 5 is the positive. So this is now on to our third example, and again we have the problem of a negative and a positive and having different signs within the expression we've been asked to factorize. So again, starting off very similar, we're working in reverse to put this into two brackets, and the only way we can get an x squared is if we have an x as the first term in each bracket. So again, we're looking at product and sum, so the plus 12 at the end being our product, and the minus 7 is our sum. Okay, so we need combinations of numbers that multiply together to give me a product of positive 12. Now here's the thing to keep an eye out for. If you ever see the coefficient of x, the number at the end, being minus and positive in that order, it has to be two negatives. And the reason being, the only way to get a sum that is negative, but two numbers that have multiplied together to give me a positive, is if those numbers were both negative, because multiplying two negatives gives me a positive. So we're looking at two negatives here. So if we consider numbers that multiply together to give me plus 12 that are both negative, I could have minus 1 times minus 12. But again, if I was to look at the sum, minus 1 plus minus 12 is going to give me minus 13, which is way off the mark. Okay, I could look at minus 2 times minus 6. So minus 2 plus minus 6 would give me minus 8. So not quite there yet. I could also have minus 3 times minus 4. So minus 3 times minus 4 does indeed give me positive 12. And it also, minus 3 take away 4 would give me minus 7. So these are the numbers that I'm looking for. Again, we bit of trial and error and process of elimination, but we'll get there in the end. So while we're dealing with factorising quadratics, I'm also going to take an opportunity to look at these types of examples where we're dealing with what's known as the difference of two squares. So occasionally we might be asked to factorise questions of this nature. So we'll look at x squared minus 25 first off. So what throws people about this is overthinking it in terms of looking at product and sum and things like that, the way we've dealt with the previous examples. This is what's known as the difference of two squares, okay? And how to spot the difference of two squares is if both terms are squared terms. So x squared is clearly a squared term. 25 is a square number, and what has to be in between them is a minus, okay? And the easiest and quickest way of thinking of factorising these is, well, what goes at the start of each bracket is the square root of the first term. So the square root of x squared is x. The second term in each bracket is the square root of the second term. So the square root of 25 is 5. And what we also, the signs inside each bracket, one has to be positive and one has to be negative. Okay? And I mean, you look at this second example, you think it's going to be a great deal more difficult. No, both terms are squared terms. 9 and 4 are both square numbers. X squared and y squared are both squared terms. So essentially, if we want to factorise this, well, the square root of 9 is 3. And again, don't forget the square root of the x squared as well. So square root of 9x squared is 3x. And similarly, if we want to square root the second term, just like we've done over here to get the second term each bracket, the square root of 4y squared is 2y. And just keep in mind, one bracket has to be positive and the other has to be negative. So that's how we tackle equations where we're dealing with a difference of 2 squared.